So good. Happy Friday to you guys. How you guys doing? George is excited. This is good. This is good. Awesome. Okay, I figured this. We're going to start chapter 4 today. So 4.1 is on the docket for today. And then Monday we'll do 4.2. And then you know what? You guys are such cool students. I'm going to just give you like 2 weeks off.
Yay! Wow. That's crazy. That's crazy. That is.
So we're going to go from there. Okay, I like this lecture. I super duper. I look forward to this lecture here in as we chart chapter 4 because it's a whole new world, a whole new way of thinking about the trig functions here. And so let me do this. Let me get myself out of the screen. Where'd it go? All right, good morning to you, the two that came in. Go for it. Sit down. Let's get started with things here. Let's see. I just need to move myself out of here. There it is. Stop video. Because it's a lot. Okay, I'm going to stop my video because I can't. Not enough bandwidth here to do what it needs to do. All right. I think we're here. Is that right? Chapter 4. Chapter 4, we're going to look at something called graphing of the trig functions here. Then we're going to take a look at the inverse functions towards the end of the chapter. So this is chapter 4, 4.1. If you want to do it on your notes here, it looks like this. And talk to me if you guys see that 4.1 basic graphs.
Yep.
Sweet. Okay. We'll start with that. Okay, and the fun stuff. This is so cool. Okay, let's do it the long by hand method, and I'll show you some other things here as we look at it. So here it is. Here, what we do. What do we do? Do you guys remember how we moved from degrees into radians? Remember that good stuff, right? And radians are actually just regular numbers. They're real numbers here. So here's what I got for you guys to do. So we could do it as example number 1. Let me put in my, let's go with it here. I'm just going to call it the sine function. And graph. Okay. This gets me totally excited here. So here's what we need to do. We need to make a table. And you guys have to do the table for me here. And we'll do it real quick here because I'll assign you guys here. So this is going to be x. And this is going to be sine of x. I'm going to use x for my value. And I'm going to use radian measurements. So we start off with 0. And we are going to do the whole entire curve. So here it is, the pi over 6, pi over 4, pi over 3, pi over 2. That's the first one, right? That's the first quadrant. Then we have, I'm going to go around the unit circle here. All these wonderful pieces here. 2 pi over 3. 3 pi over 4. That's that piece there. Some more of a table. Sorry, guys. Some work here that needs to be done. I'm going to continue the table, go a little smaller, so I get all throughout the whole entire unit circle. See, we stopped at 3 pi over 4. I'm going to go to 5 pi over 6, and then eventually pi. And we have 7 pi over 6 on our hands. It's tedious, but needed here. 5 pi over 4, 4 pi over 3, 3 pi over 2. Let's see, 5 pi over 3, 7 pi over 4. Almost done, almost done. There it is, 11 pi over 6. I think eventually 2 pi. All right. You guys see that little chart there? Are we good?
Can you give us a minute?
Say that again, because let me see if I can turn in my, oh, hold on. My volume is like down low. That's why. Okay. Now I can hear you, I think.
Can you zoom in a bit?
Oh, zoom in. Absolutely. Zoom. Not that way, this way. So we have going down the first table here. Does that help there?
Yes.
Perfect. Okay, so 0, pi over 6, pi over 4, pi over 3, pi over 2, so on and so forth. 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So if you have a calculator, if you have a chart in front of you, I'm going to assign these little values here. Now, starting from the right-hand side to my right of the room, and we're going to go down the list here. So I need exact value for each of these, and then I need the nearest, I guess 100th would be okay, to the nearest 100th. So if you have a calculator, if you don't, we're going to have to sort of help each other out. We good?
Down a little bit, please.
Say again, Namea?
Can you please slide down? Just the last one's kind of cut off. It's just too much. Wait. So, I mean, 4, 5, or 7.
Okay, you guys talk to me here. Just want to make sure. Are we good?
We're all trying to kind of confirm and make sure we have all of that.
Sure. Okay. And you guys talk to me. Tell me what you guys need here. I'm going to go like this just so the numbers are there. Okay, so I think these are all the values we know of in radian form. So real quick, you're starting on the right-hand side. I'm going to assign you guys, just give me the values, and I'm not sure if you have your books or if you want to do it by calculator, whatever you need to do it with here. So I'm going to go with, let's go down the list here. So Corinna, you have 0. Find me sine of 0 degrees. And then we're just going to go back and forth. So Hayden, you got the next one, pi over 6. Amaya, pi over 4. And we're just going down the list. Haley, pi over 3. Rylan, pi over 2. Georgia, 2 pi over 3. Grace, 3 pi over 4. Nicholas, I'm going to get you to the next table here. So 5 pi over 6. You guys, that one. Grant, you have sine of pi. Adrian, sine of 7 pi over 6. And Zechariah, you got a 5 pi over 4 on your hands. So just give me those values, and we're going to try to go in order. Okay, are we good there? Does that make sense to you guys?
You want the exact values?
I want to, let's see, I want the exact values, and then next to it, I want to know the nearest 100th. So some of you guys have it easy because some of it's just 0 or 1. Lucky. And then we go from there. So if you say on this one, you can also say skip if you need to. We're good. And then we'll kind of figure it out together here. So tell me if you have enough time. So if you have your books in front of you, you do have it on the back cover of your textbook, if that's what you have. And then also if you have a calculator, if you can remember it as well, if you can actually do it just real quickly here. Kind of like pi over 3. You're like, oh, you know what? I know this one. It goes like this. So therefore, I know this is 1/2. This is root 3 over 2. And then I go from there. We're good? So if you want to just jot it down real quick here and actually do the work in front of it too. That's technically what we should be doing. But let's go with it here. So boom, back to Corinna. Corinna, all yours, go.
0.
Awesome. Easy, lucky. Hayden. Sorry if you guys can speak louder because I can't hear you, especially if you're sort of in the back of the room. I think I hear Amaya the best and Corinna the best, but otherwise you have to speak a lot louder. Yeah, so you probably should use a calculator as well on it. So let's go with it, and we'll just work together as a class as well. So Hayden, in the back, talk to me here. What do you get for sine of pi over 6? All right, 1/2. I think that's what I heard you say, or 0.5. That's perfect. Okay, cool. Boom. Is that what you said? Maybe I should ask, is that what you said?
Yes.
Okay, sounds good. Amaya, all yours. Go.
I got square root 2/2, and then for the decimal, I got 0.71.
0.71.
1.
Yep. Perfect. Okay. Boom. Haley, pi over 3.
0.01.
It should be what? Square root of 3 over 2, right? And then it is?
Around 0.0.
It should be like 0.8-ish. And so let's see if you are in radian mode or degree mode. That's the first thing. Most likely you are in degree mode still. Or Georgia was in degree mode as she handed the calculator to you. Yeah, you could also just punch in square root of 3, divide by 2 on the calculator, and just see what that gives you. 0.87, yep. 0.866 or just 0.87 is perfect. Okay, boom. Next one, Lister Rylin, sine of pi over 2. Awesome. Georgia. Yes, so they go down. So the pattern is starting to continue, right? 0.87. See, those on the left-hand side of the room, you might just be able to do the work without doing the work. So Grace, next one, sine of 3 pi over 4.
I got 2.36, but my calculator might be.
Ooh, yeah. Let's see. So sine functions should not go beyond 1, right? So then it should stay between 1 and -1. All right, then anybody can help Grace out as well here if need be here. So make sure.
Is it square root 2/2?
That could be the case. So even Grace, check this out here because the pattern is going to continue, right? We're just looking at a circle that's going to go around this way. So if you're at this side, it's the same thing as doing one earlier. So you later people in the class here, I think you guys can find a little pattern happening here. So we go up to 1 at pi over 2. Then we go down to root 3 over 2. This guy goes down to root 2 over 2 as an exact value. And that should give you, and Grace, talk to me, just make sure you get it on the calculator. Did you get a 0.71 eventually?
No, I did not.
Ooh. Let's see. First things first is let's see if you are in radian mode. And then when you punch it in, you should say sine of, the parenthesis opens up, and you just press, make sure that parenthesis is there, but it's 3 times pi divided by 4, and then close off that parenthesis.
Okay, there, I got it this time. I don't know why.
Okay. That's cool. No problem. Okay. Everybody else, you guys can either calculate it yourself or just look at the pattern that's happening here. So, boom. Nicholas, 5 pi over 6.
It's 0.5 or
1/2 or 0.5. Perfect. Boom. Grant, sine of pi.
0.
0. Easy. Lucky. Adrian, 7 pi over 6. Perfect. Yeah, we got a -1/2 because now we're in quadrant 3. And, you just say, Mr. NG, if this is too easy now, because we actually have all that here. So Zechariah, last one for you. 5 pi over 4. Negative root square root of 2 over 2. Sorry, speak louder, whoever's speaking, or.
wait.
How about this here? We're going to have like a spokesman here in the class here. So since I hear Amaya or Corinna, if someone says something, if you can tell me real quick here, and then we'll go from there.
Nothing, never
We
mind.
got it fixed.
Thank you, Grant. Awesome. Okay, let's continue our little table here. So I think what's going to happen is this is a negative root 3 over 2, which is a negative 0.87. That's going to be a negative 1. And then it's going to go back up because now we're in quadrant 4, but it's still negative. So then it becomes this negative root 3 over 2 again. There's 0.87. Then it'd be a negative root 2 over 2, which is negative 0.71. Then a negative 1/2, which is negative 0.5. Yes, and then eventually back up to 0. Are we good?
Yeah, we're all
Okay.
right.
Cool. Okay, so first things first, hopefully you recognize the patterns that are happening here. So once we do quadrant 1, or from 0 to pi over 2, the rest is really just looking at a unit circle, seeing which way we go, and the pattern repeats itself. Okay, why did we spend literally 15 minutes on this? Here's the cool stuff. X is a real number on our hands. And sine of x is also a real number. So you have a real number connected to a real number. And so here's what we're going to do. We're going to use this as the x value. And all we're going to do is we're going to use this as a y value. So we've connected x's and y's together. So now we're back to graphing like we did in Algebra 2, connecting x's and y's. So we're going to try to get off the unit circle. So we're out of the unit circle, and the graph now looks something like this. So I'm going to go to the next slide. Are we good? So,
You're still writing.
okay. Everybody finished writing down?
Yes.
Okay. Tell me if I can go to the next slide. Can I go to the here now?
No.
No. Got to go back to here still. Okay. So I do see 1, 2. Looks like 2 people still copying down. Go for it.
Okay, you're good.
Okay, sounds good. So here's what we're going to do. We're going to make an X and Y graph paper, except it's going to look a little different because notice, I guess we should do this too here. If you were to approximate like pi over 6 and kind of do all this right here, right? So pi is going to be about 3.14. We know that. 2 pi is going to be about 6.28. So our x values really go from 0 to about 6, a little bit over 6. We good? And so our y values looks like the lowest point on our graph is -1. Looks like the highest point is +1. So we're going to stretch that out a little bit just to sort of see the graph. Are we good? So now let's jump to the graph itself. It's going to look like this. Let me make it even bigger just so we see it. And let's see if this will be fine. Okay, so graph looks kind of different. Boom. Okay, so let's go with it. Graph looks kind of funky because we normally look at 1, 2, 3, 4, 5 across the x-axis, but this time we got it in terms of pi. And notice just a few things before you guys start graphing it here. So we usually mainly go up to maybe 1 or 2 along the y-axis, or sometimes 3. So this guy went up to 4 just so we can see it nicely. Along the x-axis, notice it's chopped up into pieces of 6. So notice this is like pi over 6. This would be 2 pi over 6 or pi over 3. And so just a few things here just to kind of keep in mind. So pi over 6 is just going to be the same as pi over 6. And once you cut everything into pi over 6's, 2 pi over 6, which is the next one up, is going to be pi over 3. 3 pi over 6 is just going to be your pi over 2. Are we good? So we're just we broke everything down in terms of denominators of 6's. So as you do this, so get yourself on a sheet of paper. If you have quadrule paper, that's really cool. And so we're going to go from 0. Let's go all the way to pi over 2, marking these things up. And so my next one, let's see. So pi over 6 is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 will be the next one. And that's 2 pi over 3. Tell me if you guys agree. So this guy should be 2 pi over 3 right here. Uh, 5 pi over 6 should be just right there. That does not reduce at all, so it just stays as 5 pi over 6. And then we finally hit 6 pi over 6, which is just pi. 7 pi over 6 probably would be the next one. Are we good there? You guys talk to me. Let me stop there just to make sure everybody's on the same page. Any questions? This is so super cool because now I don't have to be stuck to unit circle. Okay, after 7 pi over 6, there's an 8 pi over 6. Reduced form would be a 4 pi over 3. So I got this one, 4 pi over 3. You know what, class, I'm going to just change it up on you guys here, just a little bit here. Along the y-axis, just so we can see the graph a little bit better, instead of going from 1 to 4, let's go, should have just went from, just messing with you. Oh man, I'm so sorry. Who has, raise your hand if you have a pin. You did it with pin. Yes. Oh man, half the class I messed up. This is super cool. Okay, so 3 pi over 2. Let's see. So we got, let's see, 4 pi over 3. I'm going to go back up to pi here. So 7 pi over 6, 8 pi over 6, 9 pi over 6. Yeah, that makes sense because you divide it by 3 gets you 3 pi over 2. The next one after 3 pi over 2 would be 10 over 6, which is half of that would be 5. Half of that is 3. So 5 pi over 3. After 10 pi over 6, I have 11 pi over 6. Are we good?
There was a lot of no's.
Okay, sure. Okay, and then the people that are done, you tell me from our first list, what's still missing? Is there any from the table that we have?
Yeah.
7 pi over 4.
Oh, that's right. Okay, so 7 pi over 4 is missing. Any others? Just real quick here. We'll place them where we need to place them. I think, go ahead. I think you guys are trying to say it. Go ahead, Karina, or I mean, or whoever was saying it. Something about denominators of 4, maybe?
Yeah.
Yeah. We're missing all the denominators of 4. We got all the denominators of 6 and 3 and 2, but how about pi over 4? Looks like 3 pi over 4, 5 pi over 4, and 7 pi over 4. I think those are the 4 we're missing. Okay, so how do we do this? So the pi over 4s are going to be a little different because notice if you go from 0 to pi over 2, right? That's pi over 2. Half of that would be pi over 4. Agreed or disagreed? Right? We take pi over 2, we divide it by 2, or we multiply it by a half. We get ourselves the pi over 4. So this little line that we've created, if you can go back and then like right here, right in the middle there, we're going to make this to be a pi over 4. It's the halfway point and kind of just judge it. It's going to be the halfway point between pi over 2 and 0. Okay, so again, we're building our little graph. After this will become easier. Promise you, do the homework and all the good stuff here, and you're like, oh yeah, that's so easy now. Okay, between pi over 2 and pi. Now we're going to get this little guy right here, the halfway point right here. So notice the 2 pi over 3 and the 5 pi over 6, they're actually kind of close to this one. This is going to be 3 pi over 4. Got that one now. Okay, the halfway point between pi and 3 pi over 2, right here, that's going to be our next one. That's the 5 pi over 4. And then the halfway point from 3 pi over 2 to 2 pi, that's going to be our 7 pi over 4. That's cool. Okay, eventually, we're not going to write all of these down. Eventually what happens is you'll recognize in the graph which one you want. Like, oh, I need this one for this graph, or I'm going to just do everything is in terms of pi over 4. Or you'll say I need everything in terms of pi over 6, depending on what you're shifting around. But for now, okay, here it is, the fun part. So let's look back at our table. And we're going to plot these points from our sine curve onto here. So off the unit circle, here we go. So sine of 0 of the x gives you a 0 for sine. So this guy is a big O dotted 0, 0. Then we have, let's see, boom. Since you guys said it before, you guys talked to me now here. So Corinna, that was 0, 0. Hayden, we have what for pi over 6? 1/2, perfect. So at pi over 6, we're going to go up to a half right there. Boom, boom. And Amaya, pi over 4. 0.7. Okay, it's about maybe like right there or so. Yeah, okay. Okay, pi over 3, Haley. 0.87, so about like right there. Perfect. Boom, boom, boom. Rylin, pi over 2.
You said 1.
1, okay, thank you so much. Yep, if I don't hear them, please tell me. Boom, Georgia, sine of 2 pi over 3. 0.807. Cool. Grace, 3 pi over 4. 0.71. Perfecto. Okay. And Nicholas, sine of 5 pi over 6. 1/2 is perfect. Grant, sine of pi. 0. Adrian, go for it. 7 pi over 6. Negative 0.5 is negative 1/2. Perfecto. Zechariah. Sorry, couldn't hear Zechariah. Are you okay? Are we good there? Just a little louder. Perfect. 0.7, negative 0.71. So that's 1/2. So it'd be about right there-ish. Okay. Okay, I'm going to finish up the rest here. Negative 0.87, negative 1, negative 0.87, negative 0.71, negative 1/2, and 0. Boom. Are we good? Okay, I think we're ready to connect this guy. So let's go for it here. So connect, and it's going to be a curve. It's going to be like almost like a little slight parabola here. So we're connecting the curve together. This is so cool. Drawing. Did you guys remember elementary school? Remember I used to connect the dots? It's something close to that. So, dun, 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 dun. And goes down. And got this little nice little curve. And so make sure you don't make them sharp points because it should be a nice curve like we drew parabolas in algebra 2. And voila, there it is. There's our sine curve. Super duper awesome. Okay, what does this even signify? Real quick here, let's do that, and then we'll do cosine after this here. So first things first, remember on the sine, on the unit circle, right? Sine can keep on going. Is that right? It doesn't stop at 360. It doesn't stop at 2 pi, right? So you keep on going. So we call this the basic graph, but also understand you can put little arrows at the end and it keeps on going. We're good. So there's that piece to it. Okay, what's the other piece is what do we do with this stuff? So notice it goes up and then it comes down, right? So maybe just a quick little view of things here. What do we do with sine curves? How are they important? Why do we use them? Is anything that changes, anything that repeats itself, anything that goes up and then comes down is modeled by this sine curve. That is the cool thing. So if you're talking about percentage, let's say it's percentage of the moon that is shown at night, right? It usually goes from what, 0 to 100% with a full moon, right? It doesn't go back down afterwards. So it goes up to 100%, goes down to 0. Up to 100%, goes down to 0. So anything that oscillates, we call it oscillating. Let's see, how about if we model on a car engine? A car engine, you got this little piston that's right here. You got the spark plug here, right? That it makes this combustion right here. And the piston is right here. And it just moves down and it moves up, moves down and moves up. That's it. It's a combustion engine, or the position of the piston is modeled by a sine curve, because I could tell you the exact position of it. It goes up, goes down, goes up, goes down. That's it. That's your sine curve. So anything, think about anything in your life that repeats itself can be modeled by one of these trig functions. Either a sine curve, cosine curve, even a tangent curve is right here. This is super cool, because with up until now in Algebra 2, we've never been able to model anything that repeats itself. We couldn't model it that way. And now here's our model for it. So we'll get into more exercises from this a little later on here. But with, let's see, 10 minutes left, we'll tackle the cosine curve next time. Let's do a few other things here with sine, because I think it'll be important. So first things first is give me the underneath the graph here, underneath the graph, let's go with, and I'll shift back and forth on this here. So I need this, and with this, what we need to do for each of these graphs here. So I need the domain of the graph. I need the range of this graph. And then we're going to talk about something called amplitude. All right, we're going to talk about something called period. And of course, the important parts are all the zeros. So 1, 2, 3, 4, 5. 5 things that we're going to judge each of these graphs by. All right, boom, let's go up to this guy here. So you talk to me here. So domain, is there any issues? Is there any times where this guy is undefined? No, huh? Notice that every single term that we had so far, every single x value gives us a y value. And so in this case, the domain is, we can say all real numbers. Let's see how the way the book does it here. Yeah, it just says all real numbers. Oh, you know what? Zeros, and then I'm going to put down here even. This should say even odd. There it is. So it would be even odd is the last one that we'll do. So even odd would be the last. So 6 pieces here. Okay, the range. You guys talk to me. The range. I know you guys know Algebra 2. So talk to me. What's the range for the sine curve? Yes.
I'm really sorry. I totally forgot what domain.
Oh, domain. Okay, perfect. Let's go. Quick lesson on domain. Let's jam. So domain is any x's that you put in that would cause something to be undefined. And so perfect example is like 3x plus 4. That's a linear function. And it goes like this, right? So the domain for this guy is all real numbers. Sometimes we say negative infinity to positive infinity. The problem that comes in with domain is anytime you have fractions. When you have fractions on your hands, you have something that looks like this. Like one. Let me just do a simple graph. 1 over x plus 2. You guys remember those from Algebra 2? Of course you do. It's the ones that go like this. At -2, notice if you plug in a -2 into here, this fraction is going to give you a 0 inside your denominator, right? And that's not good, because what happens is you have this little vertical asymptote that's right here. So your graph goes like this, and then it goes like this. So right at that -2 marker, we say that's a problem. And so in this case, we say all real numbers except x is equal to -2. We good? So there's the issue with domain. And then one more from algebra 2. We should know this is the even roots or the square roots, like something like this. So this one is just a single point. For fractions, you have single points that are issues. For square roots, you have an interval that's a problem, because we remember from algebra 2, we can't have square roots of negative numbers. So in this case, the way we solve it is we say, look, this guy has to be greater than or equal to 0 for this to work. And so when we solve this, we get ourselves this right here. So the domain of this guy is x is greater than or equal to 10. Anything at 10 would work, or anything higher than 10 works. Otherwise, it does not work. Okay, we're good there. Quick lesson on domain. Sure, no problem, no problem. This is what we're here for. We're here to learn. So this guy, look at it. There's no asymptotes here. There's no start value. That's a little bit later on. So it's all real numbers. Every single x that I can use, it's going to give me a y value. What's my range? Anybody? Range is all the y values that are used. What's the lowest y value we see? Let's see, 0, not 0. Yeah, -1. -1 is the lowest y value I see, and it goes up to +1. It does not go anywhere else. So my range for the sine function is -1, less than or equal to y, less than or equal to +1. There's my range. Doesn't go beyond that, doesn't go below that. Okay, what's amplitude? Amplitude is the middle and up to the top. So it's, maybe give you the formula here. It's 1/2 the maximum minus the minimum. And we'll just put AKA middle.
Can you explain what you mean by that?
Oh yeah, sure. No, we will. Okay, so let's go back to our formula here. So notice the maximum value that we get is 1. The minimum value we get is -1. So if you were to subtract those two values from each other here, so 1 minus a -1 gives you 2. So notice your range is 2, but amplitude deals with half of the range. Here's my amplitude. Amplitude is from the middle point to the top. If you think about waves in the ocean, that's kind of what we're trying to do. We're trying to capture the wave from the middle to the top. So in this case, the amplitude is 1 over here. It's from the middle section. It's from the middle to the top. You could say middle to the bottom as well, but it's the crest of the wave. That's what you're looking for on this one. So computationally, if we were doing it computationally, we would say, oh, that's 1/2 times 1 minus -1 gets you half of 2, or half the range, which gets you a 1. So sine curve has an amplitude of 1. All right, I got a minute. No, I got 2.5 minutes to go here. So let's do this, finish it up. What's my period? How long does it take for this guy to start repeating itself? Yes, it looks like it starts. We can't say it's pi, but we can say it's 2 pi, because notice right after this, that part is now going to be repeating this part here. Right, and so it makes this little hill, then a valley, then a hill and a valley. So tell me if you guys agree. This right here would be 1 period. of this piece. We're good? After that, it's just going to recycle itself again. It's going to go up, and then it's going to come down, then up, and then down. And so the period to the sine function is 2 pi. Okay. And I'm kind of bouncing between each one of these here. So let me jump back to the graph itself. And the question is, where's my zeros? What are my zeros? So notice I have a 0 at 0. I have a 0 at pi. I have a 0 at 2 pi. And the question is, if this graph keeps on going, what are some other zeros that I'm going to have? 3 pi, 4 pi, 5 pi, right? Everybody see that as we keep on going? And now if we go the other way, what happens if we go this way? Negative pi, negative 2 pi, negative 3 pi. It's always going to hit the x-axis at those points. And I know we're at a time almost. So what are my zeros? Here's how we write them. The zeros are x is equal to k pi. And then we have to define what k is. K is an integer. Okay, one more thing. And we're almost at time here. So you got 45 seconds to go. Even or odd functions. Do you guys remember even and odd functions all the way from algebra? So x squared is called an even function. It goes like this. Because of things in quadrant 1 reflect back into things in quadrant 2. That's an even function. An odd function from algebra was this right here. It's x cubed. So anything in quadrant 1 reflects back into quadrant 3. Question for this guy, and 25 seconds to go. Is sine an even function or an odd function? So notice this is quadrant 1, right? Quadrant 1 here. Notice from quadrant 1, it jumps into quadrant 3. And we'll talk about this more on Monday here. But we say that sine is an odd function. So a positive x positive y lends itself to a negative x negative y. Okay, that is it. That is the sine function. So just put on here odd. Okay, and we got to get out of here because we're 20 seconds past time. Well, thank you guys so much. This is it. We moved off the unit circle. We're going to do a whole new set of trigonometry here just because we don't have to deal with the unit circle anymore. All right, you guys have a good weekend.
Thank you.
Thank you.
We're taking tests from things. And the best part is not going to be affected. Thank you.
Thank you guys. Yep. Thank you. Have a good weekend.
Like, we don't understand anything.
Yeah, like
So-
I said, all forgot it. So can you keep this all out of it again?
Yeah. Going back.
Yeah. That's exactly. We don't think we're advanced enough with Trig. You should keep this out of it.
Thank you.
Bye-bye. Bye-bye.
Thank you, Mr. Landia. Have a good weekend.
Thank you so much. You too, Amaya. Bye. Cool. Adrian, you doing okay over there?
And it was slow enough bigger.
Okay, let me stop the recording here. Boom.
All right, yeah. Stuff that I missed, I might just spit up.